All right. So my mic is coming. Good. Thank you, sir. So we have a one single line with a one instruction. So this is a classification, as I repeated again, like 2 weeks ago. So we have a level, low level, and then we have a high level. In the intermediate, we have a middle language, middle level. Where is assembly language? It's actually dependence of languages because of it's related near to the machine language. So later, when you see the format, all right, the way how it looks like machine language that you learned last week and you exercise this week. Look like this example in the slide. There's the opcode 1, 2, 3, 4, and so on, and then there's the operation, and after that they have an operand like variable, the bit pattern. Looks like machine language, right? Looks like. But this is not the ARM version that we're going to learn, because of, if you see IC, when I see that a few of difference of operation in this case, but it look like. Continue. So we know the instruction set. I leave it to you about this because we done last week instruction set. Okay. If you look at to the instruction set and compare to assembly language down there, e.g. example given at R0, R1, R2. Look at to that. Looks like the machine instruction, right? But your machine instruction, it is using the opcode. And then you're following that 4 digits, 4 bits. In this assembly language, this is the thing, at RO, R1, R2. Operation in the first place, destination for the address to store or to keep or to operate that variable, which is R0 in this case, and then the operation which is variable. In machine instruction, if you look at the decision table, is number 5, if I'm not mistaken, at the value S and T. So R1 will be S and R2 will be the T. So it looks like machine language. But this is example of a piece of instructions using assembly language. Where is not on? That's this projector, right? I don't have a remote. Do I have this one? Not the remote. The projector for this turn off. This is a submit. Okay, I would like to share with you the format in the first place before we go for the type of register. Okay. Okay, this is the format. We're going to be start with underscore start, like if another programming language. We're going to import the library, and then there are segment after import the library to declare the variables. After that execution, I mean the process execution of instruction, then you compile and you run. Okay, this is for what? Oh, right. So that's the same. But in the segment of coding, you write the code of a program. You can start in the .text or .data. Then you stop. I mean, finish your coding, and then you can run and compile. Looks like, I guess, not so difficult compared to the high-level language. I really like this. Look at this example of a piece of a code. It starts with the global. You can see that it starts with the global. So when you see it start with the global, you know you can start to do the coding after underscore start. So under the underscore start, then you start to do the whatever operation that you're going to learn later. So you are lucky this semester, we are not putting assembly language as practical tests. Suppose it's a practical test. We are having many of simulator or emulator to do the coding. Okay, so we remove this one for this semester because just add up in our new module information. Then the next semester. Okay, so make sure that you can pass this course. Okay, and in the beautiful colors. I'm not going to meet you next semester. If you meet you next semester, what to do? We don't have a midterm test. We do practical tests. Next semester, assembly language. So a little bit harder compared this semester. Okay, if you look at this one, After the global underscore start, you have operation, move, move, move. So this is the example of operation in assembly language. And then we have a system call, another operation, XOR. You can see there's also another operation, XOR, system call. So operations always at the beginning, all right? And after that, they will have the register value, the location of the address where the operation is running. And after that, the variable, like a bit pattern, seems similar in your machine language instruction set. So if you have like a string, you have a text to write up. So you need to basically using the different of operation for write up. So if you see here, this is a piece of a code using assembly language to say hello world. And on your left side, you can see that we have segmentation. I showed to you global start. That's where we're going to start to do the coding. And after that, underscore start, double, dot there. And there you are at R2 and comma R3. So that is where we do our program. Start to do the coding. And then we also have dot data. So we have the different dot text and dot data. Later we look at, okay, on this. Next, what you need to know is about not only instruction set, therefore operation, and then there's a destination for location, which is register, and the rest will be the bit pattern. This is the thing, register types. Take a look, 1 minute for these register types. How many of a types register we have? Sorry, how many of register we have? A number of register we have in the assembly language? 16. We have a 16. And not all the 16 you can use. Not all the 16 you can use. Because some of a register, has been set. Okay? From our manufacturer has been set, and they were having a special function. What we can use, the register R0, R1, R2, R3, R4, R5, R6. And somehow you also can use R8, R9, and R10. But most of our programmer, developer, they use R0 until R6. And the special register, we can't use, as a programmer, we can't use R7. Take a look on R7. Students, R7. R7 is basically is for system call. I tagging there as C. As C, system call. So system call, if you do a programming, sometimes you want to terminate your program. Or maybe during the instruction set, do the process, you have an interruption. So this is the thing, we need to have a system call in operation system. So we use a SC, R7, special case. So this register we can't use, is by default for system call. So there are many types of system call in our program development, as long as we want to develop any of a case. And then we have a R11 until R15. Look at R11 until R15. So per my understanding, R11 until R15 is a low, high-level register. Because of this high-level register, there are basically special units, and they have a special function. Take a look on that. I put PC. Sorry, FC in here, and then PC counter. PC counter is exactly like our instruction set in machine language to call instruction. And then we have, that one is for R15. R14, link register, LR. You can actually read down here. I also put in here. What is LR, what is SP. Only one is not there, which is PRC, procedure call, R12. Basically, this all from the R11 to R15, we can't use. Okay, if take a look on this case, on your right side, I snapshot the memory cell for your file register. So this is how it looks like when we have a data, and then we keep and save in our storage. Doesn't matter your storage is in RAM, random access memory, external memory, or internal memory, main memory. It look like this. Okay? Which is they were putting seem like arrangement in the table. Same goes like you're sitting now. Arrangement in the table. So, for example, this guy, 1, 2, 3. 3 of this guy for A, B, C. And then this guy continue, D, E, F, G, H, I, until number 1, 2, 3, 4. So there's arrangement. So each of these arrangement has location. So this guy, your seat number 12. This 13, every single of a seat here have a number. So same goes like our storage, memory register. So if you look at this one, there are 3 things in memory register. You will see that address for each of these data of you have the location. This is the address of the location. And there is a block, like an array. Multiple columns, multiple rows. So this is how the data has been stored in the memory storage. Whatever devices, in your thumb drive, in your external hard drive, same. So we learn, if we want to call one data, probably it's somewhere from here. Or maybe somewhere from here, in any cell of this memory register. What happened? We need to have a stack pointer. So we learned today, memory cell in the storage, basically it's been arranged like a stack. Like a stack arrangement. This is stackable. So if let's say I want to pick up this student, and you, a handsome boy. This student, how am I going to pick up if I'm starting from there? So it's going to take time, consuming. I need to scan. And then this is the boy that I wanted. I want to pick up this girl. You. How am I going to combine this guy and this girl, this boy and this girl? So we need to have a stack pointer to point, pop, then I can pick up that data. Though our PC counter can increment, and after that our PC counter was sent to the accumulator. So who's going to do this? Where is the PC counter? R15. Look at that. Where's the stack pointer? R13. So R13, R15 going to help us to point and pick up from memory cell address. Is it clear? Last week, I scanning 20 students sleep in my class. 20 students sleep in my class. I understand. Andrew? Understand, right? Sleepy, right? Not you. I'm not mentioning you. I'm talking to you. Yeah. So this way, I don't know. I still want to scan using my eyes. All right? Okay. So we understand R0 until R6 is a low-level register. We can use that. But certain of R register, we can't use that. The last, which is link register, LR. So what is the purpose of a link register? Somebody can tell me? I want to check either the student do their homeworks to revise this topic. When I was a student last time, you know what? When the lecture will start, I'm going to revise myself before I enter my class. So that's it. Because, you know, I understood I'm a student, so I need to do study first, then I go to lecture, then I'm able to understand the whole concept. Yeah. I don't like to say that there are students, especially guys, students, my classmate last time, they study, the way how they study, they just focus to the lecturer, what the lecturer said. Not do revision, but they score the course, the module. So, yeah, it's pretty much smart way. All right? So for myself, I need to work hard a little bit compared to the rest. So I study first before I enter every lecture of my classes. Every classes. So I do that. So I able to understand. You can't only depending on me. I can only able to facilitate you. All right? But you need to review this, come back home, review. At the end of this slide, have a 2 link of a YouTubes. 1 link about the ARM. Okay? It's helping you to understand ARM processor. In any university, we're using ARM for our reference. We have others, like a Linux, Jasbel. We have a x86. We have that. Okay? But we refer to ARM architecture. So you come back home, you check this one. Okay, so next week we have this exercise. At least it's easy for you, and helping the others lecturers too. Okay, and then next we have another YouTube link at the end of this. This one, the YouTube link is referred to the notes of the ARM programming language, which is we're going to start to do that next week. Okay, so this is about the register. After we know about the register, pick up the G's always. Register 0 and register 6 only we can use. Register 7 we can't use. And the register 10 upwards we can't use too. And one special thing, we have CPR. Sorry, not CPR, CPSR. Yeah. What is CPR? No, CPSR. I stated there. What is a CPSR? So CPSR is another external, additional or extra bit. It only happens if, we learn about in machine language, instruction set, when we have operations of subtraction, right? When we do a subtraction operation, two numbers, negative, so they will definitely have overflow. We also have additional of binary, okay? With two numbers, they will have overflow. Somehow, some of the numbers, the total result, basically is a negative. How are we going to tell processor? Okay? How are we going to tell the processor, hey, this result is a negative value, sign. This result is positive value, unsigned. Oh, this result have a carrier. When you add up, they have a carrier. You need to add to the next left bits. How are we going to tell the processor? So, processor use CPSR. So CPSR, obviously the function to raise the flag. So we understand that we have a flag. For example, I always saying about the overflow, right? What is overflow? You. What is the conditions of overflow? Okay, I want to try, not you. You. Are you belong to my tutorial? Yeah, no. Okay, that's good. This is I want. That's the purpose. All right. What is overflow rules? There are two overflow rules. Plus, faster. Have a 30 minutes. Student, your midterm test is another 2 weeks to go. Okay, what is the overflow rules? First, the two numbers, okay, checking here. Here, I already checked here. Okay, handsome boy.
Not the mic.
It's okay, it's fine. Everybody I'm tired. Help me, please.
When you add two numbers, it has to be the same bit, and the result also has to be the same number,
Okay.
and the last number has to be the what can I say? It also has to be this. If it is not the same number, then it's overflow. Like understand, right? You understand?
He is my student, okay, from my tutorial. He want to explain, he understand, I know, because he's also asking me during the tutorial. All right, is it correct what he said? What he said actually, overflow first rule, the first number and second number, whatever operation you want to do, make sure that it's the same, from the same class. It's positive, positive, negative, negative, correct? The second rules, which is the result must be opposites of the value. If the operation of the two is a positive, the result must be negative. And then if the other way around. Thank you. Round pause. All right. So this is overflow. When the overflow, okay, when it has overflow, somehow each of the bits, when you do calculation manually, we do together, right? Manually have carrier. So the CPU need to raise the flag. So who's going to do this? CPSR. Okay? So next, take a look. This is the slide about the CPSR. And then we also slide have for the RO and R12 that I said that you can use this general of register to putting all that data, RO, R1, R2, R3, R4, R5, R6, except R7. R8 you still can use until R12, okay? But all this one have two classes. So this is what I said, stack pointer just now, and then link register. So link register, not yet, right? R14, link register, the name is the link register. You do the coding, programming in the high-level language, Java programming, right? Definitely you have one piece of a code if the condition is looping. Is it? Loop. And the condition, which is if, condition, selection. So loop, when you do a loop, definitely they have a return to the certain of destination. You loop, and then return, and then plus, I, plus. Is it? Correct, right? You, correct, right? You take a Java? I'm taking Java programming this semester? You, yeah. Okay, so for the computer system, our operator, they need to understand when there's a loop, okay, there's a value need to return to certain destination, return back. Somehow, in programming in C, if anybody familiar with programming in C, Java also the same, return 0, it means you're going to reset, right? At the end of your code, return 0. Is it correct, you? You? Yes. Is it correct or not what I said? Are you taking Java programming? No, I'm asking her. It's okay. Both of you are taking Java programming this semester. Yeah. So did you happen to write down the code, the word return 0 at the end of your code? Return 0, it means you reset, return. So you need to return to the certain destination. So compiler need to understand that. They need to return to the certain of location. If return 0, return to 0, it means now, void. So we're using link register. So register, it's happened when it has a for loops. The condition where that have a data to send, or you move the data to the certain of location. We're using link register. So this is further up, you're going to take a look yourself. Program counter in the assembly language, same, like a machine language, same. So this is the format that I showed to you. All right. This is important. Some of programming in assembly code, you can use tree address. This is a tree address. Take a look on this slide. How I know as a tree address, there are 3 variables in my program code. So I put in this box, the red box, T, C, and D. So there's a tree address. So if next, another types of addresses, second address. Second address, look at to the example. This is second address. Look at the variable TC, TD, TB, only 2 address. Just now 3. And last but not least, we have one address. This is example one address. Which one is the easier to code and to be understand? Basically, depend to the programmer. If you're familiar, you think that first, this one address is easy, so you can use one address. For me, I like 3 addresses. Okay, we take a look one by one, at least 2 or 3 minutes for this. All right. This is an example while I'm going to do the coding. I need to write the code in assembly language, okay, to execute that operation. Take a look 1 minute. The operation is B plus C, and then C multiply D minus subtract E plus F and plus A. So in high-level language, it's easy for you. I guess that you're going to declare the variable first, and then you do operation like, believe, same method in the maths calculation. So the priority, basically multiplication operation in the first place. And then you will do the rest. So same thing in the operation here. Okay, we have the operations in assembly language. You see here, this is another example assembly language, MULT. Okay, all this operation on your right side, on your left side, okay, we call mnemonics, or like an opcode, same like machine language, we call that as an opcode. But operation in assembly language, somehow, different manufacturer, different way. And we have many complex more, as I put in the first slide just now. So we have a multiplication. So we understand the first one, MULT for multiplication. And there are register, the current instruction register, which is T. Maybe you will ask me, can we use different letter? It's up to you. But popular, we're using R. R because R stands for register. So if you look at in here, this is MULT, and then we have a T here. We have a add, we have a sub, and add. So we have a T as the register, the current register. And C and D definitely is the numbering as this operation, and location for the numbering. We learned something in this case. In assembly language, eventually you call the operand, or you call the variable. Whenever you call A, or you call B, you call C, any of a variable, you need to locate this variable in location in the first place. Each of these variable need to locate the location, the address. All right? You can't simply direct to do the operation. Locate first the address. And after you locate the address, you do operation. So that is assembly language. It's very simple, not tactical at all. So this is the 3 address. Look at to the 2 address. Same operation, but in the 2 address, you can take a look how it look like. So first of all, they load. They load C, and then they load D. Why they load C and D? Some of my students, they really like 2 address because of similar like how they are think inside their brain. Their brain will see, oh, this is multiply. So multiplication operation in the first place, then I'm going to do that. I'm going to call C and D. So what happened? They locate C and D. They load first C, and then they load D. They operate C and D. This is what happened in this instruction. Load TC. So we understand that C, the data or bit pattern, going to put into the register T. So there's location for C. And then they directly put D in the T. So D operate directly to the C here. So this is 2 address. Some of students, they like to use 2 address. I like 3 address. So very rare, somebody really like first address. But if you're not familiar, you can start used to have a 1 address. So this is 1 address. 1 address, 1 by 1. They call, and then they do operation. Call again, operation. Call again, operation. Call, operation, operation. So it seems like a lot of operation, but still accepted. When you compile, you run, still. Logic, the result will be out as the output. We accept it. So this is a 1 address. So the type of addresses, we have 1 address, 2 address, 3 address. So class, read yourself this one. So we do exercise next week. Okay? Next. They have no chance for the question. Running out of time. So look at to this example instruction. Okay, I'm giving you 3 minutes. I will go for you. 2 minutes. Familiar with this instruction? Some say yes, some don't know. Okay, 2 minutes for you. We need to learn something now, okay, about assembly language. This is a beautiful about assembly language. There's no standardization on the syntax. So for the operation, for example, we have load here, we have multiplication, MUL, we have addition, ADD, we have a subtraction, SUB, and store. Okay, that's operation. You see every single of a line of this code, at the end of the code, have semicolon. Am I right? Is that compulsory? That's my question. No. You can have semicolon or you can remove semicolon. Still accepted. When you compile, you run, still can. It's workable. And the second thing, load, operation. Somehow, just now, you see the operations, it's using capital letter. In this code, using small letter. Is it? The mnemonics is using a small letter. Is it compulsory to use small and capital? No. It's not case sensitive. That's about the assembly language. That's what we learn. So let me see in this case. How many address type, address machine in here? I can see I have a 2 and another one is a 3. So the question, can we combine address, 2 address and 3 address together, or 1 address with a 2? Yes, it is. So there's no standardization. Look at to this one. Load R1, R2, R3, until at the end. So the last R actually is R6. So this is basically the register memory. Just to show to you example. So we have register 1 until R6. And they look one by one, you see B to the R1, C to the R2, D to R3 until A to R6. Simple, right? Assembly language, what do you think? It's just a matter you need to understand how you're going to place. And in assembly language, you're going to find like this. Another instruction code I will share with you. Example, yeah. Yeah, this is one of example. Eventually, in assembly language, you will see hashtag. Hashtag. So this is one of example. Operation move. To move the data to one location to another. And you will see have a hashtag there. Let me take a look on this operation. Move R0, hashtag 42. So in the assembly language, when you have the move operation, okay, basically you can refer to this and another note that I share with you. So for move operation, we have 2 types on your right side. Or even here also got. We have MOV and we have MVN. Then semantically, the meaning I also share with you there. Easy for you to understand. Move, you just move that data or that intermediate of value to the register. In this case, example, take a look. We have a move in here. Immediate value. If you see has a hashtag in assembly language, we call this hashtag as immediate value. It means we're going to take that value directively, we push to that location. In this case, we have 42, and then directively are going to move and put this value 42 to R0. It seems like machine language instruction load number 2. Right? Opcode number 2 machine instruction. Load register R with bit pattern XY. So same. So in assembly language, this is the thing. We have immediate value. So 42 can directly put in the register 0. Another instruction for the move, we have a move not. MVN. Move not. So move not here is not. It means it's like negate. Yeah, we learned about negate in the first complement, right? So same goes. If you found move not, look at to the semantic box, okay? So if you have immediate value is a 3, so it's become negative 3. You negate. If let's say you have the number 1001, then you can use move not to change to the opposite value. So they become 0110. So that is a move on. Move not. So take a look yourself later. Next, we have also operation arithmetic. Arithmetic, we have addition, sub. We also have division, multiplications, same. But somehow there are a few more complex of the operation, like what you can see here. Yeah, we have here reverse sub, one of that. And we have here subtraction with carrier for the integer, for the which is the positive value and negative value. So somehow we need to use these two, okay? So we're going to take a look on this, and I'm going to let you know, okay, what types of the operation arithmetic will be involved for your midterm test, okay? But I want you to get familiar next week about the coding first. So if you look at to here, additional also, we have operation add, we have operation ADC, add with carrier. We also have a sub and sub with the carrier. Everything is in here. It's just for you to read and understand this is the function, that is the function. Okay, in the semantics, really helpful. Next, we have also multiplication, including, we have a two type, MUL and MLA. So MLA is with the accumulate of the results. So this one, I leave it to you, you read yourself. And logical instructions, yeah, of course, we have arithmetic and logic. We also have, this is an example. We normally used to have for the bitwise clear, one of example. There's also popular for us, BIC. So you can take a look, example of a BIC in the semantic box. And yeah, this one for the compare. So for the compare, I would like to share with you, simply to understand this, we have a CMP. CMP basically for the sub operation. CMN for the additional operation. Take a look on the semantic example. Take a look on the semantic example where we use the compare. And compare required CPSR. Because of when you do the operation, somehow we have a flag. So look at to that one. In semantic box, CMP. CMP is like a sub, I say. So if we have CMP R1 and R2, so it means R1 must be minus with R2. So that is a compare, CMP. Another comparison, CMN. CMN. CMN basically for add. See the example, R1 and R2. So R1 plus with R2. So that's the most easiest for you to understand. So we can use CMP. We also can use sub for this operation, arithmetics. Look at to this example. Okay, sum of the value for the number, okay, because we understand hexadecimal is being used to representing thousands of a number. And we're taking about 8 bits of hexadecimal. So each of bit will have 4 bits. So if we have 8, so 8 times by 4, so we're going to have 32 bits. So if you look at to this question, example of the immediate value, okay, not only hashtag, you can see below that, move R0, hashtag 42, ORR, ORR for OR, R1 and R1, and there see, look at that, you have a hashtag also there, 0, and then X, right? X, FF00. So as a programmer, we understand when we see this, this is a value for hexadecimal. So when we have a hexadecimal value, what is this number? You can compare. How do I know that's number? Take a look on the calculation. I put that, my handwriting. Okay, we have a FF00, right? So we have how many positioning? 0, 1, 2, 3. So I'm going to have 0 at the most of right bits times by 16 powered by 0, and then 0 also. The second bit, 0. 0 times by 16 powered by 1. And then I have a F. F in our hexadecimal is a 15. Right. A, B, C, D, E, F. So F will be 15. Times by 16. And then we see here, positioning is 16 powered by 2. And the first F, which is 16 powered by 3. So when you calculate total up, that is the value that we need to move. and then we need to use the OR segment operation. So operand is depends. Sometimes it's using the immediate value, sometimes just call the register value, and then we need to go to the next operation to do the execution. And we also have a load, some using LOAD, load, some using LDR. So the standard, we're using LDR. Because of ARM, there are many versions I mentioned to you, right? Manufacturer, different of a version of the standard. But this is one of a that we follow and we used to. LDR, store, and the operation. And this is simple of a piece of a code. Okay, we used to use the emulator. We also can use Visual Studio. But if you're using Visual Studio, you can't to see the address in memory when you run. Okay, but if using emulator, specific emulator, so you can it can show where's location in your cell memory. So this is for addition, subtract, multiplication, division, and check. So that's an example of a question number 1, 2 until 7. So this is the piece of a code. So I need you to do your revision for this part. And at the end of this, okay, you see there's a 2 link of YouTubes. So first link is about ARM, the coding, how to write the assembly language in ARM. The second link is for ARM itself. So take a look on this for yourself, independent study, 6 hours supposed to be. All right? Okay. Any question? I believe no question. Do you have a question? About this topic? Not yet, right? Okay, I understood. Okay. I dismiss this class. Attendance. Okay, student attendance. After you take the attendance, you may go. All right? Thank you.